Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. We are going to study the session of engine mechanics. In this session, we are going to learn the centroid of hollow sections. Here, what is the centroid of hollow sections? The centroid of hollow sections means if there is a rectangle, in that rectangle there is a hollow circle is there. For such type of composite, this type of figure, plane, how to find out or how to calculate the centroid? How to calculate the centroid of such figures? So we have to subtract from rectangle this circle, then we'll get it the centroid we are going to apply. Now the centroid of this such type of sections can be found out by considering the main section, and first as a complete one as a rectangle, and then deducted this area of the circle, cut out this hole, then by taking the area of the cutout hole as negative. Now substituting this A2, suppose this is A2 and it is A1, and similarly considering the reference axis x1 and x2, this is x-axis reference axis and y-y. x1 and x2, again x1 is the positive, from that x2 will subtract negative. So similarly y1 and y2 also will subtract, then bar x bar y becomes a1 x1 minus a2 x2 by a1 minus a2, and bar y equal to a1 y1 minus a2 y2 by a1 minus a2. So this is the equation for a hollow sections. In previous sessions for solid sections there is no hollow, then bar x equal to, for solid sections, bar x equal to a1 x1 plus a2 x2 by a1 plus a2, whereas bar y equal to a1 y1 plus a2 y2 by a1 plus a2. So for hollow sections, bar x equal to a1 x1 minus a2 x2 by a1 minus a2. We can understand better by applying those expressions, those theoretical concepts in solving the problems. Then let us see here. A square hole, the square hole is there, is punched out of a circular lamina, The diagonal of the square is being the radius of the circle. It is on the radius of the circle. It is being the radius of the circle. Okay. Find the center of gravity of the remainder if r is the radius of the circle. Now how to find out the centroid or center of gravity for this such type of planes? So here it is the hollow one and it is the solid one, solid circular lamina. So how to calculate? Let us consider the main circle as the section 1 and cutout square as a section 2. Then section 1 minus section 2. For that, here we have to find out it is symmetrical about x-axis, or that means horizontal axis. That means bar y equal to 0. Bar y equal to 0 means it is symmetrical about horizontal axis. So on this axis the centroid is there. What about bar x? The bar x equal to, it is a1 and suppose it is a2. And what happened? Bar x equal to a1 x1 minus a2 x2 by a1 minus a2. So the main circle a1 equal to, what is the main circle area? A1 equal to pi r square, where r is the radius of the circular lamina, and x1, the x1 is the centroid. Now the reference axis is, we cannot say it is at the center. The center of circular lamina is the centroid. Alright, but here it is there, hollow cut section is there. For that, what is x1? The x1 equal to r. And cutout square, for cutout square what is a2? What is the a2 area of this cutout square equal to, that is half of the r square, r into r by 2, that is r square by 2, that is 0.5 r square. What is x2? From reference axis, if we consider the reference axis here, this is the reference axis yy. From this centroid, here it is x1, What about this section? That is x2. x2 equal to x1 plus r by 2. x2 equal to, this is the r total, x1, this distance, plus this distance. This total distance is what? R plus r by 2. So r plus r by 2, that is 1.5 times r. Now we know a1 x1, a2 x2. Now what is bar x equal to? Substitute here. a1 x1 minus a2 x2 by a1 minus a2. That is a1, substitute here, pi r square x1 r minus a2 0. Off of the r square 0.5 r square, and x2 1.5 times r, and a1 is pi r square minus 0.5 r square. Then if you simplify it, r cube, here it is r cube minus pi minus 0.5 into 1.5, that is 0.75. Here also r square, get r square, this is r times pi minus 0.75. This is the calculation, you can make it. Whatever value comes, pi equal to 3.14 minus 0.75, convert 3.14 minus 0.5. If you further simplify, it is in terms of the factor times factor of r. So that is bar x distance. Alright. So this is the section. In that manner, we have to calculate the centroid of hollow sections. In the previous sessions, we calculated the centroid of composite sections, simple plane figures. But here it is, we are completely focusing on hollow sections. Okay, next one. We'll consider the next. A semicircle of 90 millimeters radius is cut out from a trapezium as shown in figure. Find out the position of centroid of this figure. What is the position of the centroid? The position of the centroid, how to calculate the position of the centroid? This is the hollow section and it is the solid section. This is complete solid. From that you have to consider as the concepts of hollow centroid sections is that how to calculate. Consider the main section as the whole section, complete solid. From that subtract the circular semicircle section, then we will get it the portion of this, the portion will get the centroid of this portion. Okay, then this portion won't be here. Okay, it seems how it looks like that. This is the geometry. This is what? This is such type of cross section. How to find out the centroid? The centroid should be calculated. Let us begin. Trapezium is the section 1. That is a1 x1. It is symmetrical about a1 y1. Or how to calculate? It is symmetrical about which axis of symmetry? Axis yy. This is the axis yy symmetry. If it is axis symmetry, what about bar x equal to on this axis? That means 0. Okay, whatever bar y. Now bar y we have to calculate. That is a1 y1 minus a2 y2 by a1 minus a2. Okay. Now horizontal is extreme downward position. This is the reference axis. For this trapezium, what is y1? y1 is the distance from the centroid of trapezium section to the reference horizontal axis. Horizontal reference axis, x axis. What is y2? The centroid of semicircle section 2. Distance from the centroid of semicircle to TO2, the axis XX. So what is the y1? Yes. What is the a1 first? Area of the trapezium, ABCD. a1 equal to h times a plus b by 2. That is a plus b by 2 half of h times a1 equal to half of h times a plus b. That is what? Trapezium. So of what is the h? 120. What is a? 200 millimeters, and base is 300. Alright, substitute here, then 30,000 square millimeter. What about y1? What is y1? y1 is h by 3 times. You can substitute here a plus 2b by a plus b. That is y1 equal to h by 3 times a plus 2b by a plus b. This is what we have calculated in previous sessions for trapezium. So h is the height is 120 millimeters and area, that is what is the A here, A is the 200, B is here 300, A plus 2B. Okay, so here it is the B and here it is A, base here. A plus 2B, A is the 300 and B is here 2 times B, 2 times 200 plus A plus B. Okay, so then what is the Y1? 56 millimeters. Now semicircle portion, you know what is the area? Area of the semicircle, that is half of total area of the circle, that is half pi r square by 2 of pi into r square. What is the r? Radius, that is 900 millimeters, that is 4050 pi square millimeter. What is the Y2? Y2 is the from this centroid here to here. Yes, Y2 is the distance from this. What is this distance? Is 4 times r by 4r by 3 pi. That means 4 by 3 pi. What is the r here? 90 millimeters. Substitute here. That is 120 by pi millimeters. That is Y2. Y1, Y2. A1, A2. Substitute back in the derived expression. That is bar y equal to A1 Y1 minus A2 Y2 by A1 minus A2. That is A1 30,000, Y1 56 millimeters minus times A2 4050 pi times 120 by pi minus A1 minus A2 30,000 minus 4050 pi. Then it is the answer is the 69.1 millimeters. Now this bar Y is 69.1 millimeters. Where is the location here? It is on the axis of symmetry. And what is the bar Y? The bar Y is where it is location. This is the 90 complete radius. From here to here it is 90. Where it is location is here. Now here it is 69.1 millimeters centroid here. So is this on the geometry? Yes, but the solid object is this is one. It is not on the geometry of this subtraction. Okay, this G is centroid lies on outside the geometry of this section. So if for symmetrical section, whereas for the two lines of symmetry, it has intersection of 2 points. Alright. So thus we have to calculate the centroid of various sections. First of all, we have to locate whether when to calculate. Now the question is that when to calculate bar x and bar y, both bar x and bar y, when to calculate. Suppose when the axis of symmetry, if the plane is not symmetrical or unsymmetrical about both horizontal and vertical axis, we have to calculate both bar x and bar y. Okay, if it is unsymmetrical about to xx and yy, vertical and horizontal axis, then we have to calculate bar x and bar y. The next is that if the plane is symmetrical, if the plane is symmetrical about vertical axis bar y, that means yy axis, then what to be calculated? We have to calculate, if it is bar y symmetrical means we have to, if it is symmetrical about axis yy, that means bar x equal to 0, we have to calculate bar y. If it is symmetrical, if the plane is symmetrical about horizontal axis xx, that means what will happen? Bar y equal to 0, you have to calculate bar x. In this figure, this trapezium is symmetrical about which axis? Vertical axis. It is symmetrical about vertical axis, that means bar x equal to 0, bar y to be calculated. Now what is the coordinate of this section? The coordinate is that bar x comma bar y equal to 0 comma 69.1. So this bar x equal to 0, that means the vertical axis, it is symmetrical about which axis? Vertical axis. So we have to calculate bar y. Bar y means it is goes. So don't go for shortcuts of here you may get an similarity. Our mind will be programmed to. So it is symmetrical about y axis. So you have to calculate bar y. Symmetrical about x axis here in this third point. So you have to calculate bar x. No. In that manner, don't remember the concept. You have to come to here. It is symmetrical about bar y. Y axis. That means what about bar x? It is on that only. So bar x equal to 0. Then we have to calculate vertical distance from reference axis. That is bar y. Like that you have to remember. But don't go for shortcuts of symmetrical about y. That means you have to calculate bar y. Symmetrical about x. You have to calculate bar x. Okay. Our mind will be shortcut manner it goes. But no. That is not the way of. That is not the method of remembering these concepts. You have to remember concept-oriented memorization is highly encourageable. Alright. Coming to the next problem. Determine the centroid of the remaining area. Here it is shown hatched. This is got hatching. The color, the different color it is showing. Alright. So we consider it is a section 1, subtract from this section 2, then we will get at this hatching portion. How to calculate again? It is like, here the thing is that it is looking differently. We don't have such type of section formula. We have to divide into two simple figures. It is a rectangle 1. This is a triangle. You can consider triangle as 1, rectangle 2 in that circle. So one area of the 1 plus 2 minus 3. That is the total area. That means here it is symmetrical about which axis? Tell me. It is unsymmetrical to both axes. So bar x equal to a1 x1 plus a2 x2 minus a3 x3 by a1 plus a2 minus a3. Next, bar y equal to a1 y1 plus a2 y2 minus a3 y3 by a1 plus a2 minus a3. Two solids we joined, a1 plus a1 x1 plus a2 x minus subtracted. So simple. It's like a intersection B. Okay. And here as A union B means total combined unity, summation, a maximum value we consider. Now here a1 x1 plus a2 x2 minus a3 x3 by a1 plus a2 minus a2 minus a3. What is the area of the section 1? Area of the section 1 is a rectangle, is a triangle. That is 60 minus 30. That is here it is 13. So what is the A1? Area of the triangle of base. Base is 80, height 30. Consider reference axis xx yy. Okay, this is x1. Similarly y1. Find out x1. This is the g1 distance. Here it is somewhere else. g2 this distance. Here it is x1. From here to here, that is y1. Similarly, here it is g2, is here x2. From here to here, y2. And here it is x3. And here it is y3. Let us calculate. Let us begin. Yeah. What I explained is triangle I explained. But here they consider rectangle as the section 1. It's okay, no problem. You can work out like that also. There are various methods are there. Alright, no problem. Now what is the rectangle here? The rectangle is considered in the solution as A1. Without seeing the solution, I explained how to solve this x1, x2 and all. You consider A1, this is the section 1, you can consider whatever vice versa also, no problem. Okay. Now what is A1 here? Rectangle of length into breadth. What is the length here? 80. 40 plus 40, 80 and 30. 30 and 40 plus 40. This is what rectangle is. And what about x1? Consider the reference axis. There the reference axis. This is the reference axis yy and it is xx. Okay, what is the y1? x1? x1 equal to 80 by 2. Reference, this is the g1. That is, okay. What is that? Total, this total length is 40, 48. Total length is 40 plus 40, 80, 80 by 2. That is 40 millimeter. What about y1? That is 30 by 2. y1 equal to 15 millimeter. For rectangle individual. Next, go to Next level, this is called G2. We explained you by considering as section 1. You can consider it as section 1 also, but the methodology remains the same. Here it is x2. What is A2 of base into height? Of base is 80, height is 60 minus 30. This is the 30 rectangle triangle. 1200 square millimeter. X2. What is that X2? X2 equal to here it is h by 3. From this apex we are considering, that means 1 minus h by 3, that is 2h by 3. That is 2 by 3 times, what is the h? This is the height, that is 80 millimeters. That is x2 equal to 2/3 h. 2/3 times, what is the height? This height is 80. That's 53.3 millimeters. What about y2? Y2 from distance, from here to here, base. How to calculate y2? Again, y2 equal to, this side becomes now vertical side becomes, always remember vertical side becomes, this is another h by 3. Okay, just wait, I'll explain. This is the distance of y2. Here it is the rectangle. This distance is how much? 30. And this distance is 30. From here to here, what is the distance here? This is the vertical side portion of this is h by 3 again. That means 30 plus 30 by 3. That is 40 millimeters. Okay. Concept understand here. Suppose here it is circle, is a triangle. From vertical side, from this horizontal side to this point, here it is h by 3. Suppose it to be here it is h. Then it becomes 2h by 3 from apex to centroid. Now we are coming this side. From this apex to this centroid, g equal to 2h by 3, provided this is considered as h. Then what about this distance? It is h by 3. So that concept, by using that concept, we calculated here. From here we are coming 2h by 3. From here to here. From this side to this side, 2h by 3. So thus y2 we calculated as 30 plus 30 by 3. That is, 30 plus 30 by 3 is 10, 40 millimeters. Now coming to semicircle. The semicircle portion you have to consider, that is a negative subtraction. A2, A3 equal to pi r square by 2. Pi into what is it? R. The radius is 20 millimeters. 628.3 square millimeter. What about x3? This is the reference axis. x3. From here to here, this distance. How to calculate that? X3 equal to up to here 40 plus here, from here to here how much? 20. 40 plus 20, that is 60 millimeters. Okay. What about y3? y3 means this is the vertical distance y3. y3 equal to 4r by 3 pi. 4 by 3 pi times, what is that r? 20 millimeters. That is 8.5 millimeters. Very simple. Don't get any confusion here. 4 times 4r by 3 pi semicircle is like that. We want here, this is the portion. Okay. Okay, this is the portion we are having here. From here to here, x3. Here to here is y3. y3, if you go and study, you see that is a 4 times r by 3 pi. x3 means, what is the x3 equal to? x3 equal to this distance, that is 40, and this totally is 40. From here to here, that is half of the distance, no, that is 20. x3 equal to 40 plus 20. y3 equal to, from here to here, this distance to this distance, 4r by 3 pi. 4 into what is the r is 20 millimeters by 3 pi. That is 8.5 millimeters. Very, very important model here. This one is. Now, substitute bar x equal to, what is bar x equal to? A1, x1 plus A2, x2. These are the solid objects joined. We have to subtract which one? A3. That is A3 x3 by A1 plus A2 minus A3. That is substitute here the values of A1 x1, A2 x2 and A3 x3. Then you will get it the value of that is 41.1 millimeters. Okay. What is here? A1 is 2400 millimeters. Okay, you understand better here. What is A1? 2400. Yeah, substitute here 2400. What about x1? The x1 is 40 millimeters. Substitute here x1 40 millimeters. What about A2? The A2 is 1200 millimeters. A2 is 1200. Yeah, substitute here 1200. What is x2? x2 is how much? 53.3 millimeters. Now A3 628.3 millimeters. Okay, and x3 60 millimeters. Now this is A1 portion, A2 minus A3, A1 A plus A2 minus A3. Then we'll got it as how much? 41.1 millimeters. Now what about bar y? Bar y equal to A1 y1 plus A2 y2 minus A3 y3 by A1 plus A2 minus A3. What is A1? Yes. What about A2 here? Yes, here. What about A3? So this is connected A1 plus A2 minus A3. What about Y1? Coming back. Y1 is 15 millimeters. Y1 15 millimeters. And what is Y2? Okay, Y2 substitute here. What is the Y2 here? 40 millimeters. So Y2 here it is 40 millimeters. Y3 8.5 millimeters. Y3 8.5 millimeters. Substitute here. We got it how much? 26.5 millimeters. Now bar x and bar y equal to 41.1 millimeter, 41.1 comma 26.5 millimeters. Alright. Now how to locate here the centroid of this particular peculiar section. Bar x and bar y. Here it is 40 bar. This is the reference axis. Y bar x is horizontal distance, that is 41.1. Approximately bar x 41.1. What about bar y? 26.5. Vertical you have to mark it 26.5, approximately 26.5 height. Okay, it is above line. And bar x is 20. Yeah, bar x is 41.5. 41. It is approximately coming this point. This is the point Z. That is the centroid of this particular object. Alright. So here the centroid is on the geometry, solid geometry, hatched geometry. Okay, it is not on the hollow section. So thus we can understand from here the various sections of how to calculate centroid of a hollow sections. In this section we have covered. Okay. And very important that some of the sections, if you want to cover, you can also calculate some of the sections. You can try it. Yeah, this is an assignment. It is symmetrical about both x and y. It is a hollow is there. The size of this is 100 millimeters. And here it is another 100 millimeters for a square section. The radius is 30 millimeters. Find out the centroid of this section. Okay, it is symmetrical about both. Yeah, you find out and tell me. Alright. This is the centroid of the center of the circle is passing through the centroid of this square. Okay. And suppose if we consider another sections, here it is located here. You can also try this, and the length here it is 40 and here it is 30 millimeters. Find out the centroid of this portion. Okay, here it is 40 millimeters, all are in millimeters. Now the height is from this height to here 100 millimeters. Find out the centroid. Here the distance was given is 50 millimeters. Find out the centroid of this hatched section. What is the centroid of hatched section? Okay, these are the problems you can solve as a practice. So that with this, okay, here the hatched section portion hollow, the circle is we have to take it. When to this type of things are useful, this type of hollow sections, yes, okay, this type of hollow sections are highly useful, especially planes and all, when we are having sheets, thick sheets, which consists of we have to attach the pipes from the thick sheet to another thick sheet. Such type of sections, this type of, okay, comes under this category. So those places we need for such type of situations, we have to calculate the centroid. Comes under the category of hollow sections, centroid of hollow sections. Okay, with this we covered the centroid of hollow sections of various figures. Let us summarize. Okay, what is the hollow section? We begin with what is the centroid of a hollow section. Let me cut out the holes. So we have to make it bar x and bar y. How to calculate? There are the simple planes we consider. That's why centroid. So A1, this for two sections. So we have to, that is section 1, we have to consider the main section. From that you have to subtract the subsection, that is area of section 2. Okay, A1 x1 minus A2 x2 by A1 minus A2, that is bar x. And calculate the bar y also, A1 y1 minus A2 y2 by A1 minus A2. And one more thing, very important principle you have learned. When to calculate bar x and bar y, or what to calculate by giving the problem. So this is very important concept here. When the section is unsymmetrical about both the axes, then you have to calculate bar x and bar y. When the section is symmetrical about bar y axis, for a one line axis, it is suppose here symmetrical about y axis, then we have to find out bar y. It is symmetrical about horizontal axis x, we have to calculate bar x, that is the vertical distance. Horizontal distance comes from vertical axis. So with this we can stop now this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.